Hey everyone, and welcome back to the SaaS developer community, where we learn from each other how to build SaaS applications. And with me today, we have Ram, who is the CEO of Nile. We wanted to chat about the topic that just keeps coming up in the Slack and in the community all the time, which is multitenancy in SaaS applications. So, Ram, welcome to the show.
Hey Gwen, thanks a lot. It's been a while since I was on the pod, but we
Yeah, in the last year or so, I know you talked to hundreds of companies building SaaS. And obviously, before that, you led cloud engineering at Confluent. You and your team built SaaS. And the topic of multi-tenancy is so core to building SaaS applications. I'm kind of curious how early, if a startup is building SaaS application, how early do they even have to start thinking about multi-tenancy?
yeah, great question. So, honestly, SaaS and multi-tenant are just pretty much, if you think about it, are really the same thing. There is probably no applications that are built as SaaS applications that are not multi-tenant, largely because you're typically serving the application to multiple customers. Now the customers could be in enterprise, different um, business units or customers, or sometimes even in standard SaaS applications we talk about in terms of households. Like each household could be its own tenant, where, like, let's say you're providing a SaaS application for consumers, but the isolation and the ability to, like, think about tenants starts from day one, and everything around SaaS is in terms of your authentication, permissions, the aspect of billing. They're all in the context of a tenant. So tenant kind of becomes a foundational, I would say, element of your company and business, and everything revolves around a tenant. Another terminology for tenant could be, customers, workspaces. It does not matter, but usually it's essentially, the unit of isolation and account that you deal with your end
So
customers.
you have to worry about it from day one, but you never you can never stop worrying about it, essentially.
Yeah, that's right. So it's a journey. As companies start and as you succeed, you're going to continue to have different problems. But it's always good to think about the basics and foundations from day zero. And we'll talk about that a little bit. But that's been our experience. That's been, speaking to a lot of companies as well. That's kind of the experience of a lot of companies. Obviously, there are challenges in doing it. But, you do have to think about it from day one.
So let's talk a bit go. I know you mapped all the problems that people run into in different stages. So let's jump a bit into the details.
Yeah, so I think, when you start your day one journey of building an application, what you're really thinking about is like, hey, let me get a database, and let me build a simple backend that defines my business logic, and then probably a front end that gives the web experience for your customers. In some cases, it could be API, CLI, it doesn't matter. But when you try to do that, what you have to bake in is the right data model into your database and ensure that data between your tenants are highly secure. And the last thing you want is one customer seeing the data of another customer, right? And for all
Ye-
you know, they could be competitors. So the thing to note here is isolation of the tenant data at the database level is extremely paramount when you start. And for any company that is doing serious business and are essentially trying to sell for enterprise, when I say enterprise, it could be any B2B companies. They have to think about and take this seriously. So there are multiple ways to do this, obviously, right? Like every other problem. But to start with, you need to think about it, and that's more important. And then, if I look at within tenant isolation, you can talk about data isolation into, like, largely three different ways to do this. Hey, do I actually focus on having all the tenant data in a single database and even a single table? And do I isolate it at the application level? So that's one option, which is enforce user access, permissions, authentication, everything at the application level, and just hope that you don't have any leakage in the application to hit the wrong data set. Now, while this is doable, it has its own benefits, right? One is obviously you don't have to deal with complicated database messes. It's probably cost effective because you're kind of having all multi-tenant. But the downside with this model is you're going to have it at the application level, and you just need to be really careful that you don't leak the information. A second
And
option within the row level itself is in very, very few databases, there are options where you could probably use some semantics in the database itself to control permissions of which user gets access to which rows within that table. But again, you need to make sure that you're able to use and set the right, uh, where clauses and context when you talk to the database to ensure that the database can enforce those permissions.
and
Uh,
also, just those permission policies themselves are not always the easiest to set up and to debug. I mean, depends on database. Sometimes just the fine-grained permission model can be kind of complicated for an engineer to deal with.
like Postgres, if you take RLS, row level security, it's a can of worms, but you don't have any other option. You could use it by implementing stored procedures and some kind of like RLS mechanisms to enforce it, but it's not the easiest thing to debug and actually even figure out like whether it did the right thing. But it's definitely an option, right? But obviously the benefit of this approach is that it's great from a cost perspective. It's great from having just one single database to manage.
Yes.
But the second option would be obviously, some databases, not every database, provides this namespacing capabilities, which is within a database, you can have this namespace. In Postgres, for example, it's called schemas. And if you do have the ability to have schemas, then you could think about having a schema per tenant. Now, again, these have complications as well. Uh, the one is basically that you just have to do manual schema management in this model. The application has to ensure that it refers to the right schemas for the right tenants. And finally, you also need to, one of the biggest challenge with this model is connection management and pooling. A lot of tooling doesn't work well with, using multiple schemas and connections. And how do you pool that? So for example, if you have a set of connections to your database, how do you essentially leverage that across all your schemas? And do you need to have separate connection pools for each schema, or do you essentially have one and be able to manage that across the schemas? Does it work with like common, there are systems that actually solve the connection pool problem by being a proxy in front of databases?
Yeah.
And can they actually work with multiple schemas? All of these have to be tested out.
And
Uh,
it also kind of limits the number of customers you could have on the same database, because if you give everyone its own schema, it means that every customer has a full set of tables, essentially, a full set of indexes. Eventually, you probably just run out of database.
yeah, so a typical pattern for most applications is you're going to have 90% of your tenants to be really small, using, having little data, and then you're going to have like, around 10 to 15% with a medium amount of data, and then like less than 5% that have most of your data. And if you look at that mapping, and if you actually take the first 80% who are really small, and if you end up having to create separate schemas for them, what you really need to think about are obviously cost implications, running out of resources in terms of total number of connections, tables, indexes. You also think about how do you do kind of analytics across all your schemas. There's no straightforward way to do that. You probably have to, you get access, you can have access to all schemas, but you still have to query them separately. And the last approach could be that you have separate databases for every tenant. Now, at a high level, this seems very simple, right? Just create a new database. But remember, if you have to do this in a self-serve way, you have to provision a database in a self-serve way for a tenant, which means it's not actually fast enough. It's not going to be fast for you to like just get an instance and get a DB and everything set up and the user signs in. for a new tenant on their UI, unless you're going to go and manually set up the boxes and everything and do manual provisioning for your customer. But even if after that, you have to make sure your application can now work with like n databases. You have to think about cost implications of paying per database, and also the overhead of having all the other resources that are independent for each tenant. Now, the upside to this is obviously definitely a much better siloed, you experience, because you're going to have each DB to be its own. You could still have application mistakes where you talk to the wrong DB, uh, but again, it's all approaches have some risk. But this approach also has the challenges of how do you query and understand global analytics? How do you do admin management for all your tenants? How do you do rollout changes and schema changes? I think the same challenges that you have with per schema approach, you have it here. Um, so it's complicated. It's doable if you have like around 5 to 10 customers. Might be possible, but again, it's complicated if you think about uh, how do you actually merge them later on to be multi-tenant. If you wanted it to be, could be a more complicated situation.
And my guess is that usually the people who pick this path are the ones who imagine that the business will be, at least initially, very small number of selling to extremely large companies. So
Yeah, it's that, and also I think mentally, if you think about it, uh, if it feels easier to just like stamp out a separate DB and not think about the whole multi-tenant problem where you're going to make them all your tables think about isolation of tenants, and making sure your application and your DB everything works correctly. Even though the separate DB approach has its own challenges, I do think from a cognitive overhead, the DB approach seems much simpler because of how you think about the world. Like it's much
yeah.
easier to think about, hey, I have a tenant, I have a database. This is like, hey, multi-tenancy within a single database seems complicated at a
Yeah,
high
and
level.
you probably don't even bother with like a single application layer if you have multiple databases. You just every tenant is you
Yeah, so
stamp
you
up
could,
the application, you stamp up the database, you stamp up the DNS and connect over here. That's it.
right, right.
Yeah.
And I think one other thing I add here is tenant management goes hand in hand with user management for SaaS applications. What I mean by that is, you know, a tenant typically consists of one to many users. Uh, the normal state of SaaS is like you're going to have more than one user per tenant, and within those users as well, you need to be able to define different permissions for different tenants, right? Because each user and each tenant wants to define different permissions, accessibility for different groups of people, and they'll have even different authentication mechanisms per tenant. So it's not just about the actual data of the user, but the mode of interacting with your application in terms of how do they authenticate? Do they use what type of SSO do they use? What aspects of permissions do they have? They all have to be tenant aware, and that's pretty important. So, which is why I think user management without tenancy built in does not make sense. And you need to make sure that if you're actually leveraging external ways to enforce user management, you need to make sure that there is state, you're able to manage the state of all that within the context of tenants. So, as the tenant lifecycle happens in terms of create tenants, updating the tenants, and deleting the tenants, you just have to make sure that any other systems that you have in your ecosystem, they're all tenant aware, and the updates of the lifecycle updates of the tenant flows to all those systems as well to make sure you make the appropriate changes.
I mean, this is so important, right? Imagine that someone is not allowed to see certain information, but it's only enforced in one database, and your application actually has also an event stream and another database and so on. It's just,
Yeah, exactly.
it can
So
be a catastrophe.
right. So as I said, apart from user management, um, the whole concept of tenant is there are different types of data. There is transaction data, there is real-time events, there is metrics and analytics that typically all SaaS applications if you're going to be a real-time and data-centric app, you really have to have all those capabilities. And if you need to have those capabilities, you need to make sure that isolation is not only at your relational DB level. It happens even in, like, when I'm a tenant cannot fetch the events of another tenant, right? Or cannot look into the analytics of another tenant. All of these are data leaks, and pretty much you're breaching contracts, as well as you're leaking information. So you just have to make sure that tenant capabilities are built in across all those data formats. Now, having said all this, I don't really think, there's a lot of generally work to first think about it. And sometimes you might decide, hey, this is too much, and let me just build a single tenant app and then think about this problem in the future. This is a fine thing to do, but usually what we have seen in our experience is building the concepts, and which is kind of what most companies try to do, though it is a non-trivial amount of work, is to bake it in from the beginning. There's always trade-offs with all these approaches, right? Which is, there's a trade-off between cost, operational overhead, and security. And
So,
the way to think about which solution works for which largely will depend on your domain in which you're working and what your customers want. And not all customers want the same thing. So being able to have the ideal world would be to have an hybrid model, right? Which is, you can pick and choose for a certain set of customers to be multi-tenant, depending on what type of customer they are, and whether they are essentially, maybe in some cases, a free user or a paid user. And in some cases, you want essentially to have like dedicated all the way, not just databases, but even like your entire computer and everything to be dedicated for a customer, because guess what? They're going to pay you more, and they are essentially very security conscious. But you want, the ideal situation is, you can have something like hybrid, but it's obviously not an easy thing to build. And the other thing I want to mention here, one other thing is, when you're building a SaaS application, even though you are a startup, you could be selling to enterprise. So a lot of requirements of your enterprise company comes into play even at the early stages, and not necessarily later stages, right? So yeah, so ideal approach would be a hybrid, but given that it is complicated, you need to make trade-off between cost, operations, and security.
and what we've really seen that makes this choice so hard is that most startups want to start with the pool model, where all the tenants are in a single database. You just give the tenant ID model, you do everything in the application. It's complicated and has risk, but is seems to be the preferred choice of most startups early on. But they know that the day will come where they will have the customers that actually needs isolation, and now they just have to figure out where to fit it into their
Yeah,
future. Is that
exactly. And the key thing is, when the isolation and everything has to happen, things like your authentication, permissions, your billing aspects, your analytics, they all have to continue to work. Your internal BI. So it's,
suddenly you have to rewrite the company?
yeah, you just have to have, like, this is almost like, I was reading this in a topic, with one of the blogs around Atlassian, right? And they had a massive 2 to 3 year architectural rewrite of going into a composable multi-tenant architecture from what they had previously. It's not easy the longer you wait, but I do think, uh, what was the requirements for SaaS 10 years back and now has also evolved. So there are certain capabilities and expectations of a SaaS app that starts from day zero. Like, when SaaS started, it was rare for customers to expect high level of security, because SaaS and cloud was just getting started. But now if you go and tell them that you don't have tenant isolation, it would not even fly, right? Like, they would have a minimum expectation bar on every company to start with that. Um, and yeah, so I think that's kind of, the complicated space of uh, tenant isolation around security.
So let's say that you did all that. You picked a tenancy model. Most likely, it will be the application layer or maybe row level security. You built your app, hopefully with no bugs, and it's mighty successful, or you're growing fast. You're getting all those customers. Your database is getting filled with data and activity. Now you have to think about the performance isolation, basically.
Yeah, exactly. Now, See, different applications are different. They have different set of customers. They have very different access patterns. So some companies are going to see it earlier, some are going to see it later in terms of the journey of when they need perform they see issues around performance. But the interesting part of this performance isolation capabilities of tenants is that you're going to have the same query execute for all your tenants. Typically you're going to do some testing, you're going to find that, hey, this query works perfectly well, you're going to push it to production. The interesting part happens when all these tenants have very different data set and sizes, as well as the type of data that they store, even for the same schema. And when these queries execute on those different data sets, you're probably going to see some tenants performing worse than other tenants. And when they're performing and the query takes performs badly, they're going to impact other tenants as well, because there's no sense of tenant isolation at the database level. Honestly, right? It's very hard to do that. You're going to connect the database isn't aware of which tenant is talking to it. So the challenge with that model then is you'll have to figure out, first off, how do I even figure out which tenant is having this issue? Now, you could typically have application level metrics that you can look at the API level to see which tenant is having higher latencies. Now, the challenge with that is if a bad tenant impacts every other tenant, the latency for every other tenant could increase. So the debugging isn't as easy as, oh, guess what? The latency for this tenant is increased, which means that's the tenant that's performing badly. The rest are fine. You're going to see most of the tenants impacted. So debugging ideally have to go all the way to the database level to figure out which query related to which tenant is taking up more resources, and then be able to do something with it. But unfortunately, it's the database doesn't have this context of tenants, so it's very hard to do that level of debugging at the database level to figure out which tenant is having the problem. So typically you'll have to actually combination of your application level metrics, the query level metrics, or the database level metrics, and you kind of have to like also figure out the customer, and which customers are essentially having larger data set, and be able to like tie all this together, right? So you'll have to like, you don't have a single metric, you'll have debugging is not as easy um, to even figure out who is causing the performance issue. But let's say that's the challenge of observability
Yes,
around.
let me just 1 second stop you here, because it reminded me of something that I saw on the SaaS Slack just a few days ago. A guy called Jeffrey Sherman showed up. He asked about scaling his SaaS platform, and his complaint was that his team is rolling out features that work perfectly well for the average customer, but completely fail at the time that they even ship for their biggest customers.
Right.
And he finding it hard to test for the size of his biggest customers. So even before the first problem goes to production, just not all of your tenants are made equal, and you really need to take it into account all the way in development.
Yeah, exactly. And one other thing I want to mention here is, because these are SaaS applications, you can't just copy your customer data to your test suite, and like you can't just replicate the whole backup and say, let me run the query against every single tenant and figure out like who's performing well, because obviously it's PII data. You obviously cannot leak all the customer data everywhere. So there is no good solution, unless I do think if databases can end up becoming aware of this notion of tenants. I think from a perspective of observability and being able to figure out like getting query statistics by tenant would be extremely useful, which is kind of hard today. So now if you think about it, let's keep the observability side on one, where let's say you just somehow manage to figure out which are the tenants, or which one tenant is causing this performance issue for you. Then the question is really, what do you do with it, right? And there are a few approaches. One could be that you decide to implement quotas in terms of per tenant, which is how much resources can a specific tenant take. What I mean by that is, in the application, you might have to decide in terms of how much uh, CPU can each tenant take, and you might decide to throttle or rate limit some of your tenants based on how expensive they are. Remember one thing though, the resource utilization at the app level can be minimal, while the resource utilization of the tenant in the database level can be pretty high. So this can only be done with understanding some level of statistics that you gather about each tenant and figuring out like who's spending more time, or kind of use the latency as a proxy, and timeouts. So there are few ways you can do this in terms of applying throttling and quotas for some of your tenants. The other thing though is sometimes you may just want to like move some of them to a separate database. So imagine that this was a multi-tenant uh, database, and a few of them are causing issues. You might decide to like, hey, let me just have them to be separate. Now the downside to that is you now have to rewrite your application to work across multiple, at least two databases. You also have to have some kind of a service that does routing for them, between them. You have to think through like observability testing. The whole thing has to be thought through in its entirety. But it is doable, but it's more complicated. But from a performance isolation perspective, you really only have these choices. You either you know can put them into a separate DB, or you can decide to like have some level of throttling or quotas. The ideal state for me, I feel, is if I look at observability, quota management, and even managing big tenants. The key thing is I think these are really deep database problems that are obviously hard to handle because this context of tenant doesn't exist at the database level. But if you can essentially make these push it to a database level problem, if a solution can be built of that sort, I think it'll be very effective. Because the last thing you want in a SaaS world is be able to get metrics by your customers or by tenants, be able to like enforce quotas by those tenants at the DB level, and even be able to like say, hey, guess what? This tenant is expensive. Press of a button, move it to isolated environment. It almost seems magic, but I think being able to do something like that would be very effective. But
Yeah.
yeah, I think that's kind of the performance isolation.
I
Uh,
think for me, the most surprising thing about performance isolation, we talk about it a lot from very low level principle thing, right? Because we know it's obvious that if you're trying to share a big Kafka cluster, then you'll have people struggling to get enough CPU throughput. Like this was a really hard problem. What I didn't realize until we started talking to other SaaS companies is that even if your application is as simple as a project management system, even then you will have hot tenants because some companies will have a lot of tickets and they will have a lot of fields in each ticket and they will have all those reports that need to filter tickets with all those rules, and all this translates to actually extremely complex database queries running on, guess what, a shared database.
yeah,
uh,
and one other thing to note is sometimes it's about the size of the tenant in terms of data. It could be the number of users in a tenant, but sometimes it's just purely like they might be using your API, right? And iterating through all the data set multiple times. Even though you can throttle them at the API level, there's only so much you can do. You'll have to let them do it, and your database has to just consume, be able to work for all these different use cases. So I think even for app, like a simple application like project management, there are lots of workflows that you define through APIs, which means you could end up with like significant amount of query load. So
yeah, one Slack bot later and who knows what will happen.
right.
So yeah, and then if you manage to solve those problems, I guess you have to start worrying about scale.
Yeah. So again, as the journey goes, um, I do want to mention that some of these can all happen at different stages depending on the company you are. So there's no like this is the order that you would essentially proceed. But in most cases, what happens is if you're growing well, then the next thing to think about is like, guess what? A single database is not good enough. largely for many reasons. This could be because you have lots of hot tenants. This could be because you have a significant amount of uh, tenants. This could be because of memory usage, because of the type of queries that you have. There could be many reasons, but largely, if you hit your resource bounds, you kind of have to scale out, and that's kind of where you typically want to be able to have multiple databases. You need to be able to shard between those databases. Like what I mean by sharding is being able to place all your customers across n databases, for n being two or more. Usually you're going to have a few more. The challenge with this model is sharding itself is a complicated piece. So if you're going to have, like, say, five databases and you decide to shard, uh, you're going to have to first of all end up paying more for much lower utilization of all these boxes because you just have over provisioned it. So let's say you ended up, each database cost you like $1,000 a month, which is close to like 12K a month, and you ended up provisioning five of them. You're going to pay around like 60K, and the utilization on these boxes could just very well be just 20%. But the reason why you do this is because, guess what, sharding is complicated, resharding is even more complicated. So let me just create these static boxes and figure out resharding in the future. Let me just keep round dropping between these machines. Let me have some kind of like routing mechanism and metadata service to be able to figure out where the tenant is, rewrite the app. You do all of this,
Yeah.
but
I think that's the biggest thing, right? I mean, cost aside, going from a non-sharded system into a sharded system, even for a fair company that does it fairly early, it's like a year project or something.
yeah, so it is complicated, as you said, right? From execution standpoint, like speed of execution and being able to rewrite your entire stack, it takes up significant amount of time, which means time taken away from other feature work. It is also expensive to do in terms of just cost, because the number of people needed plus the amount of resources you're going to like over provision to be able to do this. And finally, operationally, even after you did all this, it's not easy to maintain because you're going to have n machines now, n databases to be able to manage, debug, um, look at like insights, analytics, uh, enforce permissions, authentication, everything across all the stack. So it's a huge, huge lift, um, which is kind of why I think if you can have these capabilities built in from early stages, it's a pretty big advantage. But at the same time, nobody wants to go spend all the time on these things because guess what? You don't even know if your product will work. So it's it's a hard problem, but typically you end up with that. And
That's the biggest trap, right? I mean, you know that it will be a huge pain after you're big, but there is absolutely no point in doing it before you're big.
correct. And the other thing is, in case you decided to like not have not set up too much capacity for all your machines, you could end up having to rebalance them even within the set of machines that you have, even ignoring resharding. What resharding, by resharding, I mean, let's say you ended up with like five machines and then you need to add five more machines, which is like adding 10 more machines to your cluster, and moving all your tenants across them. But even before all of that, you might have a necessity where you have five databases, you have all these tenants across them. But guess what? Some of them are really hot, which means you're saturating some boxes and not the others, which means you have to move some of them. And you need to be able to move them while the availability is maintained, right? Last thing you want is to have a downtime or send a maintenance email in 2023 saying we'll be down for like 30 minutes. So you should be able to do this, and you should be able to like do this seamlessly with for your customers. Um, Again, there are solutions, but they all take significant time to be able to do this. The ideal world, again, I think, is if you can actually pay uh, and enforce this from day one, uh, but be able to do this with almost zero cost, right? I think that'll be very ideal. But yeah, I think tenant scaling is a massive thing, and it gets even more complicated if you have to shard it across not just a single region but multiple regions.
Wait,
Um,
we did not get to multivision yet, but yeah, that is a whole new kind of worms.
Definitely, like sharding itself, uh, you have to take all that context into consideration when you design it.
Yeah, and I think you even sent around, I think we included in one of the community newsletters, as there was a blog by Notion, and this is, a pretty successful company. They went along for fairly long without sharding, and then when they decided to shard, it was a massive project. And
Yeah, exactly. And there's Notion, there was Slack, there's Atlassian. I mean, pretty much all companies go through this journey if they're successful. And in all these cases, the question is, when is it actually the right time? And oftentimes, it's not the right time is not when your users complain about performance. The right time is not when you've hit 70-80% of your resource utilization. Because there is basically a thing about how long it takes to build all this, and also customer success becomes a key point. So you don't really want to do this too late when you already impacted your brand and how customers think about your application and so on. You want to start early and think about it, and spend your company's time and effort and energy into doing that right. But having said that, obviously they all have trade-off, right? You're going to spend time, which means cost, and which means you're not going to focus on the features.
and really, like, finding the right time, now that you mention it, like a lot of times it wasn't that they ran out of machine capacity, they ran out of things like transaction IDs, or their auto vacuum could no longer keep up with the rate of changes. Like, it's just things that, I mean, you need a good expertise to even know how to detect that you're getting close to the limit.
Correct. And the worst part would be if you have to, there are many reasons to shard, as you said. This could be because your tenants are taking up resources, or your maintenance operations are taking up resources, your storage is taking up resources. And the the thing for you is to figure out, how can I do this. Obviously, just doing it is expensive in terms of just operation, the time it takes, and so on. But how can you do this in a cost effective way is complicated, largely because, as you said, if you're vacuuming and the reason for to shard is because of vacuum, for all you know, that's not really adding value to the business, because it's almost like a table stake.
Yeah, I know, right? Imagine having this conversation with your CEO or business decision maker. I need at least 25% of the engineering team, and I this much more budget. Why? Because our vacuuming is no longer keeping up. Sorry about that.
I mean, for folks who are listening in, vacuuming is the process of defragmenting your DB, because of continuous updates. Um, you're going to get into a state where you'll have to like take up resources, unused resources, and be able to like have a much more. Uh,
Yeah, I think in other cases it's called compaction sometimes, but it's like the maintenance operations running in the background to guarantee good performance in your database, essentially.
yeah. Anyway, so that's the scaling part. It's a continuous effort. It's not going to go away as you grow, especially if you are hyper growth or you have customers increasing their workloads. You're going to essentially have to continue to like deal with this issue. Again, if you can have this perfect database that can solve all these problems for you, then it's fantastic. But as long as you have to think about these problems and manage them, you're going to spend significant cost, time, um, on these issues.
Yeah, so we mentioned maintenance operations for a second, so we can talk about how other maintenance operations change as the company just gets bigger and with more demanding customers.
Yeah, and I do think, some of these, we categorize them here as tenant operations, but usually some of them happens very early and you need them early. Some of them can happen much later. But a simple thing like ch- rolling out a change. Let's say you're rolling out a schema change for a new feature, or you're creating a new index. uh, if you have to do such things, the question then is really, how do you roll out this change? Now, one option would be just make the change to all customers at the same time. Now, obviously, you're going to impact all of them if things don't go well. Uh, the a more better approach would be to essentially have forwards compatible um, and backwards compatible changes happening all the time for schema changes. Also, make sure that you have a way to slow roll it to different customers and tenants in a way where you can essentially make a change to X percentage of your users or tenants or customers, make sure it works well, and then add more stuff. Now, the reason why this is important is sometimes, uh, let's take even an example of we're talking about the query performing well for some tenants and not performing well for some tenants. So you'll never know if you're, let's say, adding another index or if you're adding another column for all you know. In some cases, you might be adding another column and you're trying to like uh, refill it from, grandfather it with data from other columns. It could be a derived column. And in such cases, you have no understanding of performance implications of adding these things to your customers' table. Now, oftentimes you might be thinking, guess what? If the application doesn't refer to those columns, you might be good. But sometimes if you have the, if you have a materialized view or if you have derived columns, you're already causing impact to your database, depending on your data size and the customer and all of that. So you just have to be really careful about rollouts. And, obviously schema change, migration rollouts is a pretty big space. But if the ability to do this in a staggered way for all your customers would be extremely valuable. Typically, the one way to do this would be to like tie all these changes to, let's say, a feature flag service that you might have, and then be able to control what percentage of your customers can have those changes be rolled out. That's one way to do this. That's one aspect of operations. The second aspect of operations is obviously this is not actually spoken about much, largely because people take backups of your database, but very rarely do you actually recover from those backups. But when you actually do, it can completely mess up because, obviously Atlassian had this very famous 2 week outage once. Um, we ourselves, in my experience, have spent time restoring data for customers. And the hardest part with these backups is it's easy to take a backup by just saying, hey, just take backup at the database, but it's very hard to restore state. Now, usually you have to restore all tables of a tenant. You can't partially restore it, largely because think about a consistent state for a tenant, and consistency is largely by time. So you're typically rewinding to a particular time and then being able to restore the tenant from that time to that time. And oftentimes you might decide, okay, guess what? I can essentially, I do have the log, the transaction log. So one approach could be that you restore from the backup at some point, and then you can replay the log after that point in time till the point at which the deletion or something bad happened. So you can get to a state before that. But more important thing is to be able to get the database to a consistent state for that specific customer. So usually it's complicated because you'll have to like do this operation per tenant or per customer or
Uh,
per set of customers.
And normally you have to actually bring up a new database, restore everything on the side, find all the data that belongs to that customer, which is an entire story on itself,
Yeah.
and then copy it over from database to database because you cannot do it in the original database. Everyone else over there didn't. It does not deserve the downtime that it takes to suddenly start recovering, overwriting all their data, etc.
Yeah. And usually what most companies end up doing is you have like a bunch of scripts written through time that lets you do this. It's kind of buggy. It has this tribal knowledge of who wrote it. Uh, Very error prone and very time consuming. In almost all companies, I've seen this take anywhere from a full day to two couple of weeks. In a case of Atlassian kind of a company, um, it's complicated. But what I think the ideal state would be is to actually have a fully automated way to test out not just backups, but be able to have a test suite where you can actually restore from backups and make sure these things actually work and they work from at the tenant level and it's fully automated. Again, it's not something that you will invest early on, but if you did have such a capability early on, it would be extremely valuable, because the ability to make your customer successful again starts from day one, right? That never changes. So having an outage of 2 weeks or 1 week or one day, even when you're 6 months or 1 year into your product development, or 4 years into your product development, doesn't change. Even if you're causing that impact to like one customer, it's a pretty big deal. So, but having said that, today there is no functionality or capabilities to have this done very easily, right? So you'll have to invest into tooling, scripts, automation, and all of this to be able to test it out and make sure it all works.
Yeah, but think about if you build it into your product, you can start offering it to your customers. Like you don't even have to be involved in restoring. You made a mistake, it's part of the product experience. Here is how you recover from those mistakes. And do you remember, I think Figma did it when they came out with this infinite undo, and how big of a deal that, hey, you can actually, in your SaaS product, you can infinitely undo anything that happened. So you have this full history. So it's suddenly one of those things that goes from being almost an operational liability to an operational competency to an actual differentiator.
Yeah,
So
very,
that's pretty cool.
yeah, that's pretty cool. And finally, on the operation front, you also have the tenant admin dashboard. Uh, and this is a common theme I hear, right? Which is, it comes under the category of, how do I get a view of all my customers in terms of their usage, in terms of performance, in terms of billing, in terms of like what is happening with which customer, in terms of contact information for these customers. Um, Typically, what happens is, if you look at the context of support and making your customer successful, either for the developers or your support team, you need to have the ability to like have a central view of, like usage, performance, who's impacted, how do I contact them, and that whole life cycle. And I think oftentimes the way you will have to achieve this is way more complicated, depending on even the architecture choices you make. You'll have to probably figure out ways to pull all this data from different sources, build your 360 dashboard, build a way for your internal stakeholders to have access to this data, including developers. Um, and it's a lot of cost, time put into it. But, if you can, this is a very important aspect that you end up having to invest, because you can't run blind. And this is not about product analytics, right? This is about just support and being able to make your customer successful.
Yeah, and I think part of it is, and it ties back to all the way in the beginning when we talked about permissions and user management. A lot of times there are cases where support is actually not allowed to access the customer data. It belongs to the customer. So you have this workflow where I'm on the phone with the customer trying to, or Zoom these days, trying to help them out. And I need a way for them to give me permission so I can access their data. And again, this is yet another thing that you kind of, and eventually, once you have customers that think about these kind of things, you have to start building it into your product.
Yep. Yep.
Cool.
Last topic. I mean, there's plenty of things we can talk about, continue to talk about around this multi-tenant journey, but I think the last topic for this pod, I would say, is worthwhile talking about is tenant placement, right? Which is really multi-region. If you look at it globally, oftentimes you're going to have customers from different parts of the world. Now, when you have customers from different parts of the world, you end up with interesting challenges. One is basically that uh, you get into performance challenges, which is like, hey, what's the latency that each of these customers are facing? Um, and that's going to be a thing to think about. There is cost challenges, which is how much cost does it take to move data from, say, one region to where the customer is, and be able to provide and all the data that they need, and including the processing cost and everything. And then sometimes it's security, which is compliance. Like, you might have, the customer might be in Europe, they might have GDPR compliance requirements. They might be related to, customer could be government, which could mean that you need FedRAMP capabilities and have be in Gov Cloud. And these are all complicated challenges with multi-region. And you also need to think about, finally, the DR strategy for your application. Now, one other thing I want to mention is most cases, it could be like, oh, just take a backup, put it in some other region, and it's not going to be necessarily fully consistent. It means that if you have a region go down, guess what? You're going to have best effort data available, which means everybody will lose some amount of data, but you still be able to recover from some point. Uh, but I think there are also more complex applications where customers might need a more stringent and secure DR strategy where they might want to have more than one copy in different regions. They might want to also You might also have to think about how fast it is to recover from your backups. Now, DR strategies, to some extent, you're taking copies of your data. Now, you could also sometimes have replication of your database, your database be replicated asynchronously to another region. Um, but with that comes the challenge of how do you do failovers, and which customer do you fail over to which region based on performance and latency, and so on. But I do think in all these cases of multi-region, what you really need is the ability to like manage different groups of tenants in different regions, depending on security, cost, performance reasons. You need to be able to then manage all these different regions in terms of operations, analytics, schemas, ensure permissions and everything is applied across all these different regions. So in a way, multi-region brings all the problems of multi-database. Uh, so it's really about, some companies don't have to do multi-region for a long time. Some have to do it early on because that's the type of customers they deal with. So depending on that, and depending on even like your use case, for example, something like a collaboration app, which is going to be kind of the future for SaaS, where multiplayer, multiple users are collaborating with your app, performance becomes critical even from day one. And you cannot essentially say, oh, performance is going to be a day end thing. That's kind of how you're going to have a competitive advantage, which means you might have to think about placement of tenants right from day one. While if it's like uh, standard typical enterprise app, like I don't know, like an expense management app, you could do away with some level of latency aspects, but you'll have the security aspects coming in there, where people may want to have their data, some enterprise companies, in secure places. But no matter what you do, ability to do these things effectively across regions will become important at some point in your journey.
So I think you covered just a lot of problems and for each company they will face different sets of challenges at different times. Is there any like bit of advice? Just I want to add on a very positive, proactive note, something we can say, hey, if you're starting a SaaS company now and you do these 2, 3 things, you'll probably be okay.
Yeah, see, I think uh, the first thing I think is important is to just be conscious about the multi-tenant journey and taking it seriously. I would definitely say that in this journey, the first phase, which is tenant isolation based on security, thinking about data isolation, thinking about user management in terms of how it works within the tenant, making sure it works across all your services like OLTP, events, metrics, and thinking about the trade-offs are definitely like what I would focus on to start with, at least. The rest will really depend on where you are and what type of application and what type of customers you're dealing with. But some of these things that I would do is definitely making your app tenant aware from day one is, I would say, something that you'll have to take it seriously, because having it tenant aware in terms of making sure your data sets and everything understands which customer it belongs to at least alleviate some of the problems in the future. But in some of the other problems, honestly, you end up having to invest a lot of time and tooling to be able to do this. Um, so you'll have to figure out what's the right point in time to do this with extreme pressure to execute on the business needs. It You'll always have to figure out what's the right time and cost. The ideal world would be if your database can solve all these problems for you, and you can just focus on your um, core feature set.
Yeah, because all of this is really data problems.
Yeah, totally. Cool. Yeah. So I think with that, hopefully this was useful. Uh, and it was great chatting about multi-tenancy.
And Ram, it was fantastic having you and all the experience you bring to the show. Again,
Yeah.
really great conversation.
Cool.